Hello, I'm Professor John Todd. I'm an academic and a consultant, and I've been interested in doing research in wood heaters and wood smoke now for over 30 years. And my role in this conversation about wood heaters is to talk about how wood burns, why it smokes, and how we can operate wood heaters better to minimise the amount of smoke. Now to start, I think the best place to start is to talk about how wood burns, so we understand a little bit about what's happening. And wood is an amazing fuel. Here's a typical piece of firewood, and obviously this is not bursting into flame. In order to make this piece of wood burn, I have to supply an external heat source. And I do this by having firstly newspaper and then kindling burning. And I put the log onto an already burning fire, and the first thing that happens is that the heat from the fire dries out the surface of this log, and the log cannot get above 100 degrees until the surface is dry, and then this dryness gradually works its way through the whole log. Now it's important for the wood itself to get well above 100 degrees. Once it starts to warm up and gets to about 200 degrees or thereabouts, the chemical reactions take place inside the wood itself, and the big molecules, the cellulose and lignin that make up the wood, at these higher temperatures, they start to break up into smaller molecules. And some of these smaller molecules at the temperatures inside the wood, and the temperature inside might be well up to 300 or 400 degrees, at these temperatures, these molecules are gaseous, so they form a gas. And these gases come off the surface of the wood, they come out of the end grain of the wood, and they come out of any cracks in the wood. And these gases are a very important part of wood burning, because it's the gases, when they burn, that we see as flame. So when we see a flame from a piece of wood, what we're seeing is gases created in the wood itself that have escaped from the wood, and they burn. Now, in order to get these gases to burn, first of all, they must be ignited. And the type of gas that comes out of wood, very similar to natural gas. Methane is one of the components, but there are hundreds of different chemicals in the gas that's coming out. But in order to get it to burn, you must have something that touches these gases that is above 600 degrees. So it has to be a hot source in order to ignite it. The analogy would be turning on the gas on your barbecue or something and not lighting the gas. The gas doesn't just burst into flame, but if you have a spark or if you have a match which is over 600 degrees, then it bursts into flame. It's the same with the gases that come out of wood. When the gases burn, we get the beautiful flame that's associated with the wood. But if the gases don't completely burn, if some of the gases remain unburnt, as they escape and cool down, the tars and oils in the gas start to condense into tiny little droplets in the same way that steam condenses. And when steam condenses coming out of a kettle, we see it as white steam. We can actually see it. It's exactly the same with wood smoke. The difference is that what we see when we see white or a faint blue colour in wood smoke is not little droplets of water, but in fact little droplets of oils and tars, tiny little droplets that are scattering the light. This is important, and I'll come back to that. The other aspect of burning wood is that as these gases escape, they leave a residue of carbon, and that eventually what we get once the gases have all burnt, we have almost pure carbon, which is what we see as charcoal. And charcoal burns very differently. What happens is the oxygen in the air reaches the surface of the charcoal, and provided the temperatures are elevated, it creates a chemical reaction that gives off a lot of heat on the surface of the charcoal. And that's why the charcoal glows red hot. It's because the heat is given off and the charcoal is heated up to 600 or 700 or 800 degrees. And when it burns very cleanly. It doesn't produce little droplets that cool, so charcoal is a very clean fuel. So when we have wood burning, as in the diagram, we see that all these processes are probably going on at the same time. But whenever you have any actual wood, not just pure charcoal, left in a fire, it's very important that there's a flame. If there's no flame, then you're getting smoke. Well, firstly, what is wood smoke? What are these things that we see as wood smoke? Firstly, the particles are very, very small. So they are, the bigger particles in wood smoke are about 1 micron, and that's a millionth of a metre across, or a thousandth of a millimetre. Very small particles, but they're the big ones in wood smoke. The smaller particles are 1,000 times smaller than that. Now, the size of the particles is very important from a health point of view. If we are in a dusty environment with sort of house dust and so forth, what happens is the nose and the throat filter out these bigger particles. So they, as the air passes through our nasal and throat passages, the big particles are filtered out. But the smoke particles, even the bigger smoke particles, pass right through our throat and into our lungs, and then the particles get trapped in the small passageways in the lungs. So they're carrying these pollutants into the lungs, which stay there. And the smallest of the particles actually are so small that they go through the lung membrane into the bloodstream. So the physical properties of wood smoke are very important. The chemical properties are also important. The chemical properties of wood smoke are very similar to tobacco smoke. So they have lots of organic chemicals in them. Some of them are known to cause respiratory problems. Some of them are known to be carcinogenic. So wood smoke, we know from many studies, is something we want to avoid wherever possible. The critical issue is how much exposure is okay and how much is not. And in the situations, in the smoke levels that we're experiencing in Tasmania and Australia, the smoke levels are getting high enough so they are causing health problems. Now, the next thing is then, why is it that wood heaters in particular smoke? For several reasons. Firstly, if the wood that we put into the wood heater, if we load a piece of wood in that is very wet, that is, it's unseasoned, what it means is that firstly a lot of the heat that's already in the wood heater has to be used to evaporate the water out of the wood. And this cools down the fire inside the wood heater, and when you have lower temperatures, the gases don't burn as well and you get more smoke. So wet wood is a problem. The next problem is that the way we operate a wood heater is that we have our fire burning merrily away and we warm the room up, and then once the room is warm, what we do is we turn the air supply down or turn it off. So we are starving the fire of oxygen. Now, if the gases that have come out of the wood, even if they're hot and even if they're well mixed with the air, if there's not enough oxygen, some of those gases won't burn. They'll get out and escape as smoke. So when we turn the air supply down, we get a bit of smoke. Another problem with the typical wood heater is that the wood heaters rely on the draft up the flue. So if we have a flue 4 to 5 metres high, and we have hot air in that flue, what it does is it causes a suction. There's a draft which draws the air up the flue, which sucks the fresh air into the wood heater. And this is how the fire operates. The draft causes a suction of air into the wood heater, and so we get the oxygen that we need into the wood heater. So if the flue is blocked, or if the flue isn't high enough, or the flue isn't hot enough, then we don't get good draft and we don't get enough oxygen coming into the heater. Another problem with wood heaters, and this is a matter of how well the wood heater is designed, if the air with the oxygen coming into the wood heater doesn't mix with the gases that are coming out of the wood. If for some reason the air with the oxygen goes straight up the flue and doesn't get mixed with the gases until you're well outside the combustion zone, then you get very poor combustion. And so it's a matter of designing wood heaters so that doesn't happen. Another problem is that, let's suppose the wood heater's been burning well and the fire has died right down, and you've got a bed of coals which might be still very hot, might be 300 or 400 degrees, but they're not glowing red hot. And you put another piece of wood on, what happens is the temperatures in the coals are hot enough to dry out the wood, and to start the reactions that cause the gases coming out of the wood, but because there are no glowing red coals there, these gases have nothing to ignite them, and so the wood just gradually it's smouldering with no flame. And this is a common problem with wood heaters, in that there is nothing there to ignite the gases that are coming off the heater, off the wood. Another problem with combustion, it sounds like there's nothing but problems with combustion, but if you have a flame, a nice flame, and you blow cold air onto the flame, what happens is that the very outside surface of the flame actually goes out. So while I said that you've got to heat the flame up to at least 600 degrees to get it to ignite, if you cool flame below 600 degrees, it goes out. So ideally in a wood heater, we want to have hot air actually we want to preheat the air that's coming in to the wood heater up to high temperatures so that it doesn't cause what's called flame quenching due to the cold air. This same flame quenching can occur if you have a cold surface. So when the wood heater is at room temperature and you first light it, even if you've got nice flame and plenty of oxygen in there, the surfaces inside the wood heater are all more or less at room temperature. And so when the flame gets close to this surface, there'll be a little section of flame that actually goes out, and the combustible gases don't burn and they get sucked up the flue, causing smoke. So we want to get the wood heater hot as quickly as possible when it's lit or when it's refueled. Another problem with burning wood is that if I had two pieces of wood like this and I lit them and I held the two pieces of wood just about 20 millimetres apart, I could get a nice flame, continuous flame between these two pieces of wood. Now if I moved the two pieces of wood right close together, at some stage suddenly the flame will go out and we'll get smoke pouring out. It's the sort of thing that can be done around a campfire as an experiment. And the reason is that when the two pieces of wood are really close together, you can't get the oxygen, the air coming in between them to sustain combustion. Another interesting thing is that if I pull these two pieces of wood further apart, once they get a certain distance apart, the flame will disappear as well. And this is because in order to sustain combustion in the gases that are coming out of the wood, this bit of wood needs the heat from this bit of wood to keep the flame temperature high enough, and vice versa. So again, another simple thing to do if there's a campfire is to have a bit of wood that's burning in the campfire. If you pull it out of the campfire, quite quickly the flame will disappear and the wood will just smoke away. So arrangement of logs so they're about 20 millimetres apart in the wood heater is important. If the wood heater is filled right up to the very brim, and sometimes you see people who want to get the heater burning as long as possible, so they pack the firebox full of wood. Well, when that happens, the problem is that there is nowhere in this hot part of the firebox where the gas is coming off the wood and the air coming into the heater can mix. So they never get mixed, and so you get a lot of smoke. So overfilling the heater is a problem. On the slide here I have an example showing just what happens to smoke. What I'm doing here is I'm loading a handful of wood shavings into a metal tin with a push-on lid with a pipe coming out of it and putting it on the electric stove, and I'm heating it up. Now there's not enough oxygen in the tin to cause the wood to burn, but once it gets hot it starts giving off lots of smoke, and you can see in the diagram there in the middle picture the smoke coming out of the tube because the wood was heated up and these gases are being formed. But then if I use a candle or a match, I can actually light that visible smoke, and you can see the flame there where the smoke is lit. In other words, smoke is unburnt fuel. So if you see someone's chimney that's smoking away, it means they're wasting fuel, essentially. You can also see where the flame is, there's no more smoke beyond the flame because the gases there are burning properly, and you get much less smoke. So it's a little example of one of the reasons why it's important for the homeowner to minimise smoke because it makes their combustion more efficient. Now, the way in which in Australia we deal with wood heaters, there are several things. Firstly, we encourage people to burn them well, and I'll talk about that in a minute, but we also have Australian standards where heaters have to be designed and tested to achieve certain emission limits, and there are Australian standards for how much smoke comes out, and there are Australian standards for how efficient the heater is. At the moment in Australia, the emission standard says that you are permitted up to 4 grams of smoke for each kilogram of wood that's burnt. Now, interestingly, in New Zealand, which uses the same standard, they say, okay, we only allow 1.5 grams of smoke per kilogram of wood burnt. So clearly there is scope for improving the design of the Australian heaters. And in fact, at the moment, the Australian Standards Committee is reviewing this, and hopefully we'll get more demanding standards in future. They're also important from a smoke point of view as the installation standards, and every heater that's installed in any house in Australia, according to the building regulations, must meet these standards. And these standards require a minimum height of flue of 4.6 metres, and this is important because it causes the draft. The flue must also extend at least a metre above the roof, and if it's near the pitch of the ridge line of the roof, it must be at least 600 millimetres above that. And all of this is to do with improving the dispersion of any smoke that is emitted. Now, most importantly, and I think this is the key message I'd like to get across, is that the way in which the wood heater is operated can have a huge impact on how much smoke is produced. In the laboratory, we can have a wood heater, we can have the same fuel, and if we operate it really poorly, we can get 100 times more smoke than if we operate it really well. So just by changing the way we operate the heater, we can get up to 100 times more smoke. So this is a very important issue. Now, the reason why people operate the heater poorly, partly it's because people are ignorant. They don't know how to operate a heater well. Some people are distracted or careless. They haven't got time to keep an eye on how the wood heater's burning. Some people are quite stubborn. They feel they know how to do it and they're not prepared to listen to anyone else's advice on how to operate a wood heater. Other people might be indifferent. They might not realise how dangerous wood smoke really is, and they might not realise that they're causing potential health problems to themselves inside their house and certainly to their neighbours. Other people are recalcitrant, that is, they just don't like being told what to do. So hopefully we can get the message across on how to operate a wood heater well. Now, there are a number of things here that I'll run through quickly. Firstly, when lighting the heater, it is really important to use enough kindling and enough paper to get the fire going quickly. So really you want to have a good fire going within a few minutes, not leaving it to smoulder away for half an hour before you have another go at lighting it. So that's very important. And the reason this is important is because of this internal surfaces. We need to get the heater, the surfaces inside the wood heater, hot as quickly as we can. One good way to do this is to set the fire, and before you light it, loosely crumple up 2 sheets of newspaper and put it on top of the load of wood that you've got in the fire, and then light it. And what this does is the newspaper on top of the load of fuel burns very quickly, and the heat from that heats up the flue, and because the flue gets hot, it starts sucking more air into the heater, and so you get, firstly, it's much easier to light a fire that way, and secondly, it heats up much quicker. Now, here are a few photos of a good way to light a heater. In this case, the heater is a very old heater, so it's not some modern new heater. But I just want to illustrate that even with an old heater, it's possible to light it so that it burns cleanly very quickly. In the photograph, there is some loosely crumpled up newspaper on top of the kindling, and then more newspaper under the kindling. The fire is lit and the door of the wood heater is just left slightly ajar. And the reason for this is that when the fire is first starting, it's good to have a little bit of extra oxygen coming into the fire in order to get it going quickly. The first photograph shows the fire 1 minute after it was lit, and the whole firebox is full of flame, and the paper on top of the load of wood is burning very rapidly and heating everything up quickly. The second photo shows the fire after 2 minutes, and here the fire has died down a bit because the newspaper, particularly the newspaper on top of the wood, has burnt away, so there's not so much flame in there, and this is a very critical stage of getting the fire going. In this case, we can see there's still flame present, the door is still slightly open, and the wood is just starting to ignite. It takes a couple of minutes to get that kindling well alight. At this time, so this is outside with that same heater, 2.5 minutes. So it's very early on in the burning process, and we can see against the trees there just a faint plume of smoke. And that's about as much smoke as you should ever get out of a wood heater. From then on, the smoke started decreasing as the heater started to warm up and the fire started to burn properly. Now we see the fire in this picture 3.5 minutes after it was lit. The door is still slightly open and the kindling is now well alight and burning well. This is good. It's getting a good vigorous fire. The firebox is starting to warm up, and outside the smoke is starting to get even less. After 5 minutes, the first smaller logs are added to the fire. The kindling's going well. The door is closed, and because the fire's already hot, there's plenty of air coming through, the logs catch very quickly, and there is almost no additional smoke. So there's an example of within 5 minutes lighting a fire and only getting really a very faint amount of smoke. The advantage, of course, is that you have the heater operating and giving off heat within 5 minutes of lighting it. And so this is good for the householder as well. Now I'm going to use the next few slides just to run through other issues associated with operating a wood heater well. And this next one is very, very important. Whenever additional wood is put into the wood heater, it is essential to leave the air control fully open for about 15 to 20 minutes. And the reason for this is that, as I said, when wood goes in, firstly it's got to dry out, so you want to get a hot fire to dry the wood out. You also want to get a hot fire to reheat the surfaces in the wood heater, and also to get the surface of the wood nicely charred so you get cleaner combustion. So this one thing, by leaving the air control fully open for 15 to 20 minutes after refueling, is that one thing will halve the amount of smoke over the full burn cycle of the heater. People say, oh well, I like to burn overnight, and if I do that, I'm burning away all the wood. No, you're not burning away all the wood. What you're doing is you're drying the wood out and you're warming up the heater and you're getting a much better combustion. And so it makes very little difference to how long the heater burns, but it just burns much more cleanly. So always leave the air control fully open for 15 to 20 minutes after refueling. Sometimes when you refuel, if the coal bed has cooled down below 600 degrees, you put the wood on and there is no flame present. So it doesn't matter whether you've got the air control fully open or not, you just don't get any flame. And if you don't see any flame within about 20 seconds, 30 seconds, it's important to get a bit of newspaper to put it in and light it, because the wood heater will be giving off the gas. There's just nothing there to ignite it. And if you do this, you will often see there'll be a whoomph, and suddenly the wood heater will be full of flame. And before you put the newspaper in and lit it, all that gas that was in there was just going up the flue and coming out as smoke. Another issue with the sorts of wood heaters we have in Australia, very common, most wood heaters in Australia have a nice glass door, and the air that's coming into the wood heater comes in above the door, which is a good thing because there's a little box there that preheats the air, so it's hot air that's coming into the firebox, and it flows down the inside of the glass and comes down the inside of the glass, which keeps the glass clean, and then flows into the base of the fire. And it's a very good design. Now the problem is if you load a piece of wood across so that it blocks this air that should be going into the base of the fire, what happens is the oxygen that's coming in, preheated oxygen, is just going straight out and up the flue. It doesn't get into the fire, it doesn't mix with the gases. So putting a log the wrong way, the logs should either be front to back so that they're perpendicular to the door, or if you do have to load them crossways, you always have to prop one end of the log up on another log so the air can get in underneath it. And that's very important as well. Another important thing to do when operating the wood heater relates to the use of fans. Now a lot of wood heaters have what they call a convection fan, a fan that you switch on and it blows air around the back of the wood heater and back out into the room, and you get a nice flow of hot air coming out into the room. Now this is great if the wood heater is burning well. So if you've got the wood heater burning fast, so with a lot of air, that's great. But if you run the fan when you first light the heater, or when you're running the heater slowly, so it's the air supply is turned right down, what the fan does is it cools the firebox and the flue too much. It gets the whole system too cold. And so the cold surfaces, the reduction in draft means that there's not enough oxygen coming in and you get a lot of smoke. And in the laboratory, by running the fan when the heater was burning very slowly on overnight burn, by leaving the fan on, this caused the biggest increase in smoke of all the different things we've done. So only operate the fan when you've got the heater burning well on high. A few other things which I've already referred to. If you put too much wood in the heater, there's no space for the gases and the oxygen to mix, so you get a lot of smoke. Another thing is if you try to burn one big log, you run into this problem because there is no adjacent log, and what happens is you put a big log into the heater and maybe the edges of the heater are still warm, and so you see that the flame is appearing and you go, yes, that's good, the fire, one big log is burning well. But what you don't see if you go off to bed is that perhaps 15 minutes later, as the heater cools down a little bit, suddenly the temperatures get too low, the flame disappears, and you have this big log that just sits there and smokes for the next 6 hours until it turns into charcoal, and then it starts to burn, okay. And this is when people are in bed. And this is one of the reasons why we get a lot of smoke overnight, because people are trying, well, a number of reasons. Some people are trying to burn a single log. Other people have just forgotten to run the heater for 15 to 20 minutes before turning it down. So this is a period, this is when smoking can be a problem. Another thing that I think is very good is every now and then go outside and have a look at the smoke from your own heater. If you're sitting there inside, you've got no idea really whether your heater's smoking or not. And I don't think people need to be silly about this. It's not a matter of rushing outside every 15 minutes to see if the heater's smoking. But now and then go out, check it just after you've refueled it sometime or when you light it. And every wood heater is a little bit different, and see if you can get it so that you only ever get a wisp of smoke out of the wood heater no matter what you're doing. The final thing I want to talk about is heater maintenance, and this is quite important too. And there are really two important things to do for maintaining a wood heater. One is to make sure the creosote does not build up in the flue. So if creosote, which is basically unburnt, these are the tars and oils that have condensed on the inside of the flue, they can build up and they can get quite thick, and gradually they block off the flue. And the more they block off the flue, the less air is coming through, the more the heater smokes and the faster it blocks up. And in extreme cases, I've seen a section of flue where all you could do was just fit a pencil up a little hole up the middle of the flue, and all the rest was creosote. So clearly the heater's not going to burn well under those circumstances. The other thing which people are less aware of is that ash can build up on top of the baffle plate. So most wood heaters have a horizontal baffle plate, and some ash gets carried up and collects on top of the baffle. It doesn't happen very quickly, but over a full heating season you can get quite a lot of ash on top of the baffle in some designs of heater. What I suggest is get a metal coat hanger or something, or a bit of stiff wire, and bend it so you can sweep around on top of the baffle. And if there's a lot of ash coming down, spend a bit of time making sure that the baffle is clear of ash at the end or at the start of each heating season, so that you get a good flow of air and you don't block it off. Now the sign of getting either a blocked flue or a ash on top of the baffle is that when you open the door to refuel it, you often get smoke coming out in the lounge room. This is quite dangerous. You can get dangerously high levels of pollution in the lounge room if you're doing this, and also the heater gets harder and harder to light. So when you first had the heater, if it was easy to light and it never smoked into the house, and then it starts to smoke or it gets harder to light, then that's an indication that you need to have your flue cleaned and your baffle cleaned off. Now, if all of these things are done, you can operate a heater so that it produces much less smoke. And if everyone did this, we estimate that there'd probably be maybe as little as 1/10 as much smoke in the urban environment by getting everyone to operate their heater well. Thank you.